안녕하세요 여러분, 혜리입니다. So in this video we're going to study trigonometry and we're going to start with radian. So radian is another way of measuring angle. So far we know one of the measurements, degree, right? And now we're going to learn radian. So pi, as we all know, the pi equals to 180 degree. Okay, so then if we want to convert, for example, 30 degree into radian, then what can we do? We can multiply by 180 degree, pi over 180 degree. Why? Because using this definition, we can say that this or this, right? Because so 180, both sides divide by pi, we have 1, or both sides divide by 180, we also have 1, right? So what we're basically doing here is that we're multiplying by 1, so it's not affecting the value. So this degree, the unit, cancels out, and we will have pi over 6. And similarly, when we have something like 3 pi over 4, let's say, then in order to convert this into degree, what we can do is that we can multiply this by 180 degree over pi. So we can see that we will have 135 degree. Then what if we have something like 3? So 3, is there any unit? There's no unit, right? That means it's radian. So radian does not have a unit. Well, sometimes we can put a unit called rad, but normally we don't put any unit for radian because radian is the ratio. So 3 here, we can, again, if we want to convert this to degree, that means we multiply by this. So we will have 540 degree over pi. Okay, so that's the simple unit conversion. And where can we apply this radian? So for HO students, you'll see a lot of this in complex numbers. And for many of the trigonometric calculations with the angle, you will use radian a lot, especially in something like calculus or in also trigonometry as well. So please be familiar with radian, okay? Now, one of the application of using radian we can think of is that, so if we have a sector here, let's say it's like theta degree, then how do we find the area of this sector? We use the ratio times pi r squared, right? And the arc length will be very similar. So we will have this, right? Then what if the angle is in radian? Then let's say the angle is just in radian. So let's say we use x. Okay, let's still use theta. So just theta in radian. Then 360 degree is 2 pi, right? That means we will have this, okay? And for the arc length, similar thing. So we will have this. So we will have theta r for the arc length, okay? Right, now let's go to the, so this is just learning another unit of angle, and now we're going to start trigonometry. So first, let's start with the definition of trigonometry. So as all of you probably have learned already in MYP or IGCSE math or any like middle school math, so when you have a right angle triangle, then you'll have the longest length as the hypotenuse and opposite with adjacent, right? So we define that sine theta is the ratio between the adjacent, not adjacent, opposite to hypotenuse, and cosine theta as adjacent over hypotenuse, and tan theta as opposite over adjacent. And what we can do here for tangent, so we said it's opposite over adjacent, right? And why don't we multiply 1, where that 1 equals to hypotenuse over hypotenuse? That means it's opposite over hypotenuse times hypotenuse over adjacent. We can do this, right? Switch the order because multiplication order doesn't really matter, right? And this is in fact opposite over hypotenuse divided by adjacent over hypotenuse. And we know that that equals to sine. And that equals to cosine. So for tangent, we can write it as sine over cosine. Okay, so not that hard. So that's the basic definition of trigonometry. And using this definition, what we can do is that when you have a problem like this, so for example, let's say sine theta equals to 4 over 7 and theta is between 90 and 0, and we want to find cosine and tangent. Then what can we do? We can form a right angle triangle using the definition. So what this means is that the hypotenuse is 7 and the opposite is 4. So using the Pythagoras theorem, the adjacent would be 49 minus 16, so root 33. So that means cosine theta would equal this, and tan theta will be root 33 over 4 over root 33, and if you want to rationalize it, you can do that. So this is how we can find the other two ratio when we know one ratio, okay? Alright, then one thing, the reason why the angle, the value of the angle has been restricted is because we can have some different values when the angle is not between this. And I'm going to explain that later when we learn the full graph of trigonometric functions. So what's next is that we have to know some special angles. So the exact values of trigonometric ratios with special angles. Okay, so for special angles, there are 3 kinds. So for this one, I'm going to use both degree and radian. So if you guys are not familiar with radian, you can look at how I can compute the degree. But please practice and get familiar with radian, okay? Radian will be very important. So let's consider equilateral triangle with length 1. So since this is an equilateral triangle, that means every angle is 60 degrees, right? And why don't we divide this by half and then make it as a right angle triangle? Or if we divide by half, then this length would be half, right? Then using Pythagoras theorem, this length would be root 3 over 2. Then what can we do? So we know that using this triangle, sine 60 equals to root 3 over 2 over 1, which is root 3 over 2. Cosine 60 is 1 over 2 over 1. So 1 over 2 over 1. That means 1 over 2 divided by 1, so that's still 1 over 2, right? And tangent 60, we will have root 3 over 2 divided by 1 over 2. So if you're not really familiar with operations of fractions of fraction, then you can always use the definition of fraction, which means that you're basically dividing the numerator by the denominator, right? So this is what we will have for tangent 60. So in your exam, when you're not allowed to use your calculator and when you have to find the value of the special angle, then you can recode this derivation and then compute it. But honestly, memorizing these values would be the best. Okay, so this you use it when you can't remember it. Okay, so we have seen 60 degrees and now let's see 30 degrees, and let's try to rotate this triangle a bit like this. So still the hypotenuse is 1 and the opposite here would be half and the adjacent will be root 3 over 2. So sine 30 degree would be 1/2, right? 1/2 over 1, so 1/2. And cosine 30 degree would be root 3 over 2, and tangent 30 degree will be 1 over root 3. Okay? Now, then what about 45 degree? So we can't really find 45 degree using equilateral triangle. So what we're going to try is that we're going to try an isosceles right angle triangle. So let's say this length is 1, that means this will be root 2 using Pythagoras theorem. And since this is an isosceles triangle, isosceles right angle triangle, so this would be 45 degree. So that means sine 45 is 1 over root 2, right? Opposite and hypotenuse. Cosine 45 degree is still 1 over root 2. And tangent 45 degree will be 1. Okay, so we have observed how we can find the exact values of special angles. So we have seen 60 degrees, 30 degree, and 45 degree. So we have seen these special angles for trigonometric ratios, and what we're going to do next is that we're going to look for the values of trigonometric ratios for some different angles, another special angles where you can't really draw a right angle triangle with them. So for example, 0 degree, 90 degree, 180 degree, and so on. Okay, so in order to do that, we need the concept of unit circle. So unit circle is just a circle with radius 1. Okay, and the main point about unit circle is that we can express every angle in right angle triangle. So I just said that I can't draw on a right angle triangle with 0 degree, right? Well, it is, because 0 degree, that means it's just a flat line. Or 90 degree, that's this, right? How can we form a right angle triangle with it? But using unit circle, we can find the trigonometric ratio of those angles, values of trigonometric ratios of those angles. So what we can do with unit angle is that when we have a certain angle like this, then we can just make a vertical line from horizontal line, so this perpendicular line, to form a right angle triangle, and where the radius is always 1. So for different angles, for example, that is bigger than 90 degree, then that's also fine. So that means, so it's always in anti-clockwise, and we start from here. So if the angle is bigger than 90 degrees, that means it's somewhere like here, right? And how do we form a right angle triangle? Simple, just create a vertical line, okay? And we can find the trigonometric ratio of that obtuse angle. Then what about the angle is beyond 180? Again, don't worry, you will have something like this, and you can still draw a right angle triangle, okay? And lastly, it's the same for 270 to 360. So let's try to look for the values of those specific angles. So let's start with 0 degree. Oh, and I have said that I'm going to look for the radian as well. So for the previous case, so 60 is the same as pi over 3, and 30 degrees is the same as pi over 6, and 45 degrees is the same as pi over 4. So that means sine pi over 3 is also this, or tangent pi over 3, cosine pi over 6, cosine pi over 4. Okay, so they have the same value. And for simplicity, I'll just stick with degree first. And yeah, we can have enough practice in radian with other examples. So yeah, coming back to sine 0 degree. So let's see what happens to the opposite when the angle is 0 degrees. So let's say we have a specific angle like that, this theta, and we can form a right angle triangle like this, right? But if theta gets smaller and smaller, what happens to the opposite? The opposite, which refers to the y value, will decrease, and then it will eventually be 0. And what about the adjacent? It's getting bigger and bigger, and then it will eventually be 1. And the reason why this is 1 is because, again, it's a unit circle. Unit circle is just a circle with a radius 1. So sine 0 degree means that opposite equals to 0. Then what about hypotenuse? Hypotenuse is always 1. Because the radius is 1, so hypotenuse is always 1. So we have 0 for sine 0 degree. Then what about cosine 0? As I said, the adjacent becomes 1, right? So 1 over 1, that's 1. And tangent 0, we can use the fact that opposite becomes 0 and adjacent becomes 1. So 0 over 1, which is 0. Well, we can also use the fact that tangent is sine over cosine. So sine over cosine 0 divided by 1, so we have 0, okay? Alright, then let's look for the case where we have 90 degree. So 90 degree is this, right? So we can observe that as the angle gets close to 90 degree, what happens to the opposite? It becomes larger and larger and larger, and it will eventually be 1. And what about the adjacent? So this is the point that we're tracking, okay? So if as this point moves to 90 degree, right? That means the x-coordinate, which is the adjacent, gets smaller and smaller, and it will eventually become 0, right? So sine 90 degree, as the opposite eventually becomes 1, it will be 1. And cosine 90, so adjacent eventually becomes 0, so 0 over 1, which is 0. Then what about tangent 90? So we know that tangent is sine over cosine. That means 1 over 0, which is undefined. Okay? Alright, then let's look for 180 degree. So sine 180 degree. So let's use the same fact. 180 is here, right? So obtuse angle, this is how the triangle looks like. And as the angle gets larger and larger, and when it gets close to 180, what happens to this opposite? It becomes smaller and smaller and smaller, and it will eventually become 0, right? So 0 over 1, which is 0. Then what about cosine 180? So we see that adjacent here gets bigger and bigger and bigger, and it eventually becomes 1, right? But note that this adjacent, do not consider it as a length, consider it as a position. So that means the adjacent here will become -1 because this x coordinate will eventually be -1. So cosine 180 will become -1/1, so it's -1. Note that hypotenuse here is always 1 because this one is the length, but this adjacent here and the opposite, we are tracking the position of the not particle, but position of the point, right? So when the point is between 90 to 180, we can see that the x coordinate is negative, right? That's why we have negative value for the adjacent. Then what about tangent 180? So again, as what we can use, we can see that tangent is sine over cosine, so it will become 0. Then what about sine 270 degree? So 270 is here, right? And we can see that as the point gets close to 270 degree, what happens to the opposite? The opposite gets larger and larger, and it will eventually be 1. But again, we're tracking the position of the point. That means at this point, the opposite is -1. So it's -1/1, so that's -1. And cosine 270 degree, so we see that adjacent eventually becomes 0, so it's 0/1, so it's 0. And lastly, tangent 270 degree, it's 1/0, so it's undefined. Okay? Then what about 360 degree? Do we have to consider it? In fact, no, because it's exactly the same as sine 0, cosine 0, and tangent 0. So sine 360 has exactly the same value with 0 degree, okay? And moving that on, so 450 will be the same with 90, and then yeah, so it repeats over and over and over by 1 revolution. So this is how we can observe the specific values for this angle. And what we are going to see next, what we are going to do next, is that we're going to find the values of sine, cosine, and tangent for specific regions. So first quadrant, second quadrant, third quadrant, and fourth quadrant. So when the angle is between 0 and 90 degree, as you can see from this diagram, both the x coordinate and y coordinate are positive, right? That means all the lengths are positive. So what that means is that sine is larger than 0, so it's positive. Cosine is also positive, and tangent is also positive. Okay? Then what about between 90 to 180? So between 90 to 180, that means this is where the angle is. So we see that the point is here, somewhere here. So the y value, which is the opposite, is positive, but the adjacent, the x value, is negative, right? So sine involves with opposite only. So that's why it's positive, because the opposite here is positive. But adjacent is negative. That's why every ratio involving the adjacent would be negative. Right? Then what about between 180 to 270 degree? So doing the same thing. Now in this case, both the adjacent and so x value and y value are negative. So that means adjacent and opposite are negative. So that means sine is negative, cosine is negative. Then what about tangent? So tangent is sine over cosine, and since both sine and cosine are negative, that means tangent must be positive. And lastly, if we want to find, so we look for the value of angle between 270 to 360. So in this case, sine, again, it's negative because you see that the opposite here is negative, right? Y is negative. And adjacent is positive, so cosine must be positive. And since one of the sine and cosine is negative, tangent must be negative. So summarizing this, what we have is that we have A as TC, and many students memorize this by old school teach crap. So it means that, so for sine, cosine, and tangent, they're all positive. For this region, only sine is positive. For this region, tangent is positive. And for this region, cosine is positive, okay? So this is how we can find the values of sine, cosine, and tangent with different domain. So different values of angle, okay? Now what we are going to do is that we're going to learn how to sketch. So I've already explained, I've already used the basic sketch of trigonometric functions in function chapter. So what we are basically doing is that we're trying to use the facts that we have made so far, and then using these facts, we're going to sketch. So for sine x, alright, so I'll use y equals sine theta because we have been using theta for angle. So we know that sine 0 is 0, sine 90 is 1, sine 180 is 0, and sine 270 is negative 1. And again, sine 360 is identical to sine 0. So using this, what we can have is that we can plot some specific points. So that's 1, and that's negative 1. And also, if we use some of the values here, 30, 45, and 60, then we can kind of sketch this, and this is what we will have for sine. And note that sine is always symmetrical. So it's symmetrical like this, and it's symmetrical like this. And they're also symmetrical, but just symmetrical by 100. So how should I say? Okay, symmetrical. So have the same value but the opposite sign. Okay, and it's the same for this. So using this symmetry, you can find the values for example, 120, 135, or 300, etc. Because, for example, 300, that means it's here, right? And what's the difference between 60 and 300? 60, right? That means it's the same as this, but just the opposite sign. So what you can do is that you can use the symmetry to find more special angles. So if you want to find those more special angles, I strongly recommend you to use this graphing technique, okay? So this is the graph of sine, and let's analyze this graph a bit. So we see that the range is from -1 to 1, as we have already studied in function chapter. But why is it restricted from -1 to 1? Why can't it go beyond? So remember, the definition of trigonometry ratio is that sine is the ratio between the opposite and hypotenuse, right? Can opposite be bigger than hypotenuse? And for any triangle, the answer is no. And it can be 1 for the case where the angle, so as we have already observed, it can be 1 when when the opposite equals to hypotenuse as like in straight line, but for any other angle we can see that it cannot go beyond, the opposite cannot go beyond the hypotenuse, right? So that's why the value of sine must always lie between 1 and -1. And actually note that it goes on and on. So yeah, it's just repeating over and over. So what we can get from here is that the amplitude is defined as the distance from the maximum point from this line of symmetry, and you can quickly calculate the amplitude by finding the distance of the maximum and minimum and divide by 2. Okay, so that's the amplitude A. And what about the period? The period for trigonometry for sine is defined as 2 pi. Okay. All right, then let's sketch cosine as well. So using what we have again, so cosine 0, 90, 180, and 270, and again 360. So cosine 0 is 1, right? So first plot the points that we know, and then using the other values we can kind of estimate that the sketch, not estimate, so the sketch looks like this, okay? And again, like in sine, so it repeats over and over. So it's the same, that amplitude of cosine is this, okay? And the period is the same, 2 pi, because it repeats by 2 pi, right? And last, tangent. Oh wait, sorry for using the radian suddenly. So yeah, that means 360 degrees. Sorry, 360 degree. Yeah, I'm used to sketch tangent using radian, so yeah, I'll stick with degree for simplicity. So this is what tangent graph would look like. Okay. So is there an amplitude? No, because there's no such thing as maximum, right? It's just keep tending to infinity. It's keep getting bigger and bigger, so no limit. Then what about the period? So period of tangent is 180 degree, right? 180, and it repeats by 180 again, right? So that's the basic properties of the 3 trigonometric functions, okay? One more thing, and then that should be it. So we're going to learn one of the most basic trigonometric identities. So we've actually learned one already, which is this. So tangent is sine over cosine. And this identity is very important that you will use a lot later. And the second identity we're going to do is that, so consider a right angle triangle, and with, let's say the hypotenuse is A and the angle is theta. Then this opposite and adjacent, we can write them in terms of A and theta, because sine theta is opposite over A, right? That means the opposite equals to A times sine theta. And similarly, cosine theta equals to adjacent over A, the hypotenuse. So adjacent, we can write it as a times cosine theta. Then we have the 3 length, and it's an right angle triangle. So using Pythagoras theorem, a squared equals to a squared times sine squared plus a squared times cosine squared. And a is clearly not 0, so we can divide all terms by a squared, or both sides by a squared. So that will yield this. And this is the very fundamental identity that we will use a lot, especially in calculus or other trigonometric function identities as well. So yep, so that's the identity that I was talking about. One last thing is transformation, but note that we've already done transformation in the transformation chapter. So remember this. So I have already made an example of using trigonometric function to do transformation. So remember that when you have to sketch a function, it's better to follow this step. And this step, you don't really have to memorize it, because you can notice that, so we do the bracket first, right? And in the bracket, we do the multiplication first. So multiplication, then addition, right? And then outside the bracket, multiplication and addition, right? Or subtraction. So follow this step to sketch, and when you have to describe the transformation, we usually group up the shift as in translation. Okay, so for description you can do this, but when you have to sketch, you can follow this step. So when you have to sketch something like this, then this is what you can follow. Okay. All right. So please watch the video of transformation. And one thing to remind is that when you have something like this, and when you have to find the amplitude or the period, what we can do is that amplitude, oh wait, sorry, for the previous case, it shouldn't be, it's not transformed yet, so sorry, a must be 1, right? So as you can see, a equals to 1, so a equals to 1, and there's no amplitude for this. But for this case, where a doesn't necessarily be, a is not 1, a can be something else, so amplitude will be a for this one. And what about the period? We can find the period by 2 pi over b. Why? Because the period of, oh wait, this is for sine. Yeah, so the period for sine is 2 pi, right? But what does it mean by times b on x? It means a horizontal stretch by a scale factor of 1 over b, which means that for every x related value, we multiply by 1 over b. And this period is certainly related to x value, right? This is a period 2 pi. And then if we multiply, if we do stretch, horizontal stretch, that means this period is also affected, so that the normal period 2 pi, it will be multiplied by 1 over b. That's why we have the equation for period like this, and it's the same for cosine as well. So it's the same. Okay, but what about tangent? So tangent, does it have an amplitude? No, right? But what about period? The period for tangent is pi. That means if you have something, so if you make a horizontal stretch by a scale factor of 1 over b, that means the period of tangent must be pi over b. Okay, so this is how we can analyze the transformed trigonometric function. So that's it for this video, and in the next video, so we have covered the very basic things of trigonometry, and what we're going to do next is that we're going to solve some geometry questions, so like learning some more rules, so sine rule, cosine rule, and area of a triangle, and something more with identities as well, so some further identities. Okay, so that's it for today, and see you guys in the next video. Bye.